Hello friends, welcome back. Now we are going to start topic 3, which is the last topic of this chapter, that is construction of the similar triangles. Now in the first chapter we have already learned that how to match the triangles. Now for example, if triangle ABC is similar to triangle PQR, then you have to take the matching sides or matching angles. For example, if you take the AB, that is first and second, then here also you have to take P and Q. Okay. If you take BC, then you have to take QR. If you take CB, then here you have to take RQ. Correct? So let us see that if one triangle is given, then how to draw the similar triangle if the sides are in ratio. For example, AB and PQ are in the ratio 5:2 or 7:3. How to draw that triangle, that we will learn in this topic. Now suppose ABC and PQ are ABC, triangle ABC is similar to triangle PQR, and here they are given. First of all, you should able to draw the triangle properly, okay, because one triangle you have to draw. Here they are given AB is 3.6 centimeters, BC is 4 and AC is 4.2 centimeter. Everywhere we are going to use the SSS or SAS property in the similarity, side angle side or three sides. Now here they are given 3.6. I'll draw ABC theoretically, A, B and C. So definitely there will be angle PQR. So if we have drawn the AB as a base, then here also draw PQ as a base and R as a top vertex. Okay, they are given that AB is 3.6, then BC is 4 and AC is 4.2, and then they are given that corresponding sides of ABC and PQR are in the ratio 2:3. Ratio is 2:3. Correct? If the ratio is 2:3, that means I have drawn the figure little bit wrong. How? Because if it is 2:3, that means this triangle sides are bigger than this triangle sides. But just forget it, because this is a analytical figure. Okay? But if it is possible in exam, if you want to draw a proper logical figure, that means show this angle smaller and this angle bigger. Right now I read the ratio 2:3 letter and drawn the figure first. But in exam, read the example carefully. If it is 2:3, then show this triangle smaller than this triangle. Okay? Just forget about it. We will see how to solve this. How to draw the similar triangle PQR similar to ABC. Very simple. All the sides are in the ratio 2:3. That means AB upon PQ will be in the ratio 2:3. Correct? First draw this triangle. Three sides are given. You can easily draw this triangle. I am telling you the solution now. Okay? First draw this triangle. Now we have to find out the measurement of all the sides. How will you find that? Simple. AB first to PQ. So AB upon PQ is equal to 2/3. AB is 3.6 and PQ is unknown. So from this equation you can easily find out what is PQ. PQ is 3/6 into 3 divided by 2. Correct? You can easily draw PQ now. In the similar fashion, find out the measure of PR. Now we want to find a PR. So AC upon PR. You have to take the adjacent sides. Corresponding sides you have to take. So if you are taking first and third AC, then here take first and third PR. So AC upon PR is equal to 2 by 3. So you will get the value of PR. Similarly, CB or BC, BC upon QR, correct? So BC upon QR is equal to 2 by 3. So you can find a value of QR also. Now all three sides are known, so you can construct this triangle, correct? So this is very simple. Let us see one more example for finding out the similar triangles. The triangle RST and UAY, triangle RST is similar to triangle UAY. Do not write here by mistake YAU or AUY something. See, because the triangle, if you take only RST as a triangle, then this triangle can be, the name of this triangle can be SRT also or TSR also. But here we are talking about the similarity. So the sides are corresponding sides. Okay. Now what they give? RS is 6 centimeter. We have to draw the analytical figure. Okay. First read the problem. RS is 6 centimeters. S is 50. ST is 7.5. The corresponding sides of both the triangles are in the ratio 5:4. Construct UAY. 5:4. 4 is lesser. So we have, this is bigger triangle and this is the smaller triangle. Here they have given RST, and since RST is there, we will write UAY, corresponding vertex. They have given RS is 6 centimeters, then S is 50 degrees and ST is 7.5. ST is 7.5. Now constructing this triangle is very easy. One thing, be sure or be fixed in your mind that only the measures of side will change as per the ratio. The ratio they are given is 5:4. 5:4. Angle will not be there in the ratio. Angle will be angle. Angle is same. If you take, no, because I am telling you, because I have seen in the paper that they're taken like this. 50 upon A is equal to 5:4. And they found something different angle, and the figure will never look similar if your angle is changed. So angles are not in the ratios. Angles are angles. Now it is very easy to construct this triangle. How you will construct that? First, you can draw this triangle. RS is given. Though they have asked to construct that UAY, you have to construct this also. Okay. So RS is given. You can draw 6. Take a ray of angle 50. Mark 7.5 here, and this triangle is completed. Correct? Now, this angle will be 50 only. RS upon UA is equal to 5:4. So you can find out UA. TS upon YA is equal to 4:5. So you can find out YA also. And the same way you draw this triangle, you can draw this triangle. So this is how you are going to draw the similar triangles. So please pause your video here, calculate these two sides and construct this triangle, similar triangle. Please do it now. Let us see one more example. Triangle RKN is similar to triangle RKN is similar to triangle SPV. Triangle SPV. Now their RN. First draw the triangle RKN analytically. So we will draw this triangle. They are given that the RK is 6.4, angle R is 60 degrees, angle K is 50 degrees. And we have to draw the triangle, both the triangles we have to construct. Rn upon SV is equal to 4:3. Rn upon SV, see, Rn SV is equal to 4:3. How will you construct both the triangles? Simple, very simple. Draw RK first, 6.4. Both the angles they are given. Draw two rays. Where those two rays will intersect each other, there you will get point N. Correct? Now, RK, Rn upon SV is 4:3. So definitely, these two triangles are in ratio of 4:3 sides. Correct? So we have RK upon SP will also be in ratio 4:3. So we have RK, R and K, first two letters, upon SP is equal to 4:3. So we have 6.4 upon SP is equal to 4:3, and you can find out SP here. Once you get SP, both the angles will be same, and you can construct this triangle SPV similar to this. Because base known, base angles known, you can easily construct this triangle. So please pause your video here and construct the triangle SPV and RKN also. Please do it now. Now we'll see the different method that without calculating we will try to construct the triangles. That means we will not calculate the ratios. That means side upon side is equal to ratio and find out the side and construct the triangle. We will not do that. We will use some different method. Let us see one example. Triangle PSE. Triangle PSE is similar to triangle TSV. TSV. Now can you see that S is common in both the triangles? Previously we have seen that the points were different, but here the points are same. One point is common here. Point S is common here. So in this case, how shall we proceed? That we'll see. They have given PS is 4.4. Let us draw one analytical figure first. Let us draw the triangle PSE first. They are given PS is 4.4 centimeter. PS is 4.4 centimeter. SE is 5.1 centimeter. 5.1, and PE is 5.5 centimeter. And we have somewhere point T and V, which are for the second triangle. S point is common. That means one vertex is here, so that triangle will be somewhere here. Okay, correct? Because PS and TS, that means T will come somewhere here, and your V will come somewhere on the AC. Let us see how to draw this triangle. They have given that PS upon TS is equal to 5/3. PS upon TS, T is somewhere here on this segment. T is somewhere here. Now how to draw this? 5.3 is given. See, one method is very, very sure that you can definitely, all the ratios will be 5.3. You can definitely find out the dimensions of the TS, TV, ST, etc. and construct the triangle inside here. That is for sure. By mathematical calculation, you can find out all the sides, and so that you can draw the triangle. That is the first method. That is the one method. The second method is, that we'll see now. Now they are in ratio 5:3. Which is the larger number? 5. So I will draw one line. I will draw one line at any angle here. Any angle. This angle is not important. You take sufficiently larger angle. Now I want 5 parts of this. So take any distance in your compass. Fairly big distance. Any distance in your compass and go on marking this. First point, same distance. That means put your pointer here, first arc, then pointer here, second arc, pointer here, third arc, fourth arc, fifth arc. Means 1, 2, 3, 4, 5. 5 parts are there on this ray. This SP, we will connect this line. Here. Okay. Simple up to this. Whatever the larger number is, make those many parts in this line, extended line. This is the constructed line. Okay. Join this. Now, to locate the point T, what you have to do? You have to just draw a line parallel to this. You have to draw that line at a distance 3. That means 1, 2 and 3. At this point, you have to draw a line parallel to this line passing through this point. Now how you can draw that? We know 2 methods. The first method is first draw from this point on this line perpendicular bisector or the perpendicular, and then whatever line is there, draw perpendicular through that line. But that is the lengthy method. Okay, a lot of construction is required in that. Instead, we can use alternate angles. That means if this angle is there, we can draw congruent angle to this angle through this point. The first term, that is, let me call this point A. SAP and let me call point B. SBT. That line will intersect in the T. So how will I draw this? Put your compass. See, angle congruent to angle SAP. How will I draw? Take in a compass, mark here, then this distance, and so I will get point somewhere here. Line parallel to this, parallel to this. This don't look parallel, but it is parallel. Consider. This is my point T. Okay, when these two lines are parallel, I got the point T. Now I have to mark the point V. V is on this side, AC. Same method I am going to use. I will draw angle, whatever the angle may be. I will draw angle congruent to angle P at T. So how will I do this? See, the base is same, SPE and STV. How will I do? Again, congruent to this angle, I will put my compass here, mark one arc here, similarly marking arc here, and whatever the point of intersection is, then we will get a particular point. You join that, there will be line parallel to SP. Whenever I extend this line, I will get my point V, and that VT is parallel to EP. So without any calculation, I have drawn or I have constructed the smaller triangle. It is very easy. Again I am explaining. First draw that bigger triangle, whatever the given triangle is. Okay, some ratio will be given. In this phi is the larger figure. So I will draw any line, and on that line I will make these many parts. Larger number. These parts are there. Now the fifth part will connect here, and the third part through that point I will draw a line parallel to this. That means I will draw a congruent angle to this angle. So these two angles are congruent and these two angles are congruent. Wherever this angle meets SP, my point T is there. So another point I got, point T. Now I want this point. How will I get this? Whatever I done here, the same thing I will do here. I will draw congruent angle to angle P at point T. base is same, one arm is same. So by you know how to draw the congruent angles. Okay, we have learned in the introduction session. If you don't remember, see the introduction session again. Learn how to draw the congruent angles. Okay, I'll tell you shortly. Put a compass here, make an arc. Similarly, same distance, put here, cut the base and make arc. Now from this point to this point, I'll take a distance, and from here I will cut the arc. So I'll get this point of intersection here somewhere. I'll just connect that point and extend wherever it will cut the AC. My point V is there. Very simple. You don't have to calculate anything in this case. You have to construct the similar triangles. The same thing you can do by calculating and then constructing. But why to do all those things? If you know the second method is very easy. You have to draw just two congruent angles. That's all. And your figure is complete. Triangle LMN is similar to triangle LQP. Triangle LQP. LM and LQ are in the ratio 4:7. LM upon LQ are in the ratio 4:7. Now remember, LQ is more than LM. So this triangle is bigger triangle. Another triangle is a bigger triangle. Okay. Now whatever they are given, first we'll draw the simple figure. Let us construct this triangle first. The triangle LMN will draw first. LMN. This triangle we have to draw. They are given LM is 3.6. Then they are given angle L is 50 degrees. And they are given Ln is 4.2. Ln is 4.2. Correct? Same method. No change in the method at all. You can draw this triangle very easily. First draw Ln 4.2. Take an angle 50 degrees, ray of 50 degrees, and then cut 3.6 on that. That is your point M. So the first triangle is completed. But LN and LP. So P is point here somewhere because this triangle is bigger triangle. So what I have to do? I have to extend this line now. I'll extend this line. My P will be somewhere here. Now what to do? Now it is, see, this is extended. Okay. Now what to do? My point P will be somewhere here and Q will be somewhere here. Which is the bigger figure? 4 or 7? 7. So I'll draw any line here. Take any distance. 1, 2, 3, 4, 5, 6, 7. My Ln is also in Ln upon LP. The point somewhere will be here. Is also in the 4:7 ratio. So for smaller triangle, ratio is 4. So 1, 2, 3, 4. I will join this. Okay. Now I have to find out the point P. So I will make use of alternate angle. I will draw the congruent angle to this at point 7 here. At this point, I will draw congruent angle. So you know how to draw congruent angles. So my line will be parallel and my P will be somewhere here. I got the point P. Okay. Now what I will draw? This angle and that angle at P will be congruent because SAS properties of the triangles, similar triangles. So what I will do? Now at point P, I will draw congruent angle like M and L. This angle I will draw congruent here. This angle. So that while drawing that angle, just you know the procedure of drawing the congruent angles. So my line will be somewhere like this. And this is my point Q. And this is how I draw the similar triangle. Now this angle, these two angles are congruent, and these two angles are congruent. This is the one line and one line. If the second triangle is smaller, it will come inside, otherwise it will be outside. What I did, 4:7. 7 is the bigger number. So first I drawn any angle, and then I took certain distance. That is also depend on you, whatever distance you want to take, but just take care it will not go outside the paper. Okay, 7 parts I have to put, 1 2 3 4 5 6 7. In the first triangle the ratio number is 4, so I connected this to fourth point. Correct? Now I have drawn the congruent angle at the point, at the 7th point here. So whatever that line is, that will intersect, ln extended, and I will get the point P. Now forget about down part. Now I want this angle congruent to this. So simply I will draw a congruent angle to N at P. Wherever that will intersect your line LM extended, you will get Q. And your similar triangle is constructed. Very simple. You don't have to calculate anything. Just by geometrical calculations you can do that. Okay. If in the exam they said that just construct both the triangles, they have not mentioned whether to do calculations or not, then you can use any method. But if they say that without calculations, okay, by geometrical construction method, then you have to follow this particular method. Okay, so read the problem carefully and only then proceed. So let us move to exercise 3.3, which is based on the constructing similar triangles. Thank you very much.